Part 2 of systems of equations with problem solving. So in this problem we have Lucas began a 110-mile bicycle trip to build up stamina for a triathlon competition. Unfortunately, the bicycle chain broke, so the athlete finished the trip walking. The whole trip took 4 hours. If the athlete walks at a rate of 3 miles per hour and rides 31 miles per hour, find the amount of time spent on the bike. So we have these two scenarios. We have walking and riding. So let's set up a table here. So distance equals rate times time. And the two scenarios are walking and riding, right? Because we're on a bike, the bike chain broke, so then we had to walk. So they tell us that the rate that we walked at was 3 miles per hour, and we rode the bike at 31 miles per hour. It's really quick. What else can we say? Well, we were on a 110-mile trip, and the whole trip took 4 hours. So we have amount of time walking and riding. Let's say walking took us X amount of time and riding took us Y amount of time. So that will allow us to create a system. So then we say rate times time is 3x, rate times time is 31y. So the two distances put together, so the amount of distance I traveled walking plus the amount of distance I traveled riding is equal to the amount of distance of 110. That's the total amount that we win. Now what we also know is that we were traveling for 4 hours total. We're on this bike ride here for 4 hours total. So the amount of time we walked plus the amount of time we rode is equal to 4. And there is our system. Just like that. So the tough part here is identifying that column there, the time column, of understanding, well, I don't know exactly, so I could say X and Y. And then you could also, there's also, a very valid way of doing this where you say that one is X and then the other one is 4 minus X, because we know if we did one thing for an hour, the other one had to be 3 hours, or one was 2 hours, the other one had to also be 2 hours. You could do that where you say X and 4 minus X. That's completely fine too. But using that wouldn't then create a system. That would just have like an equation. So we want to use a system here. And then now we just solve. So I'm going to subtract Y from both sides. I'm just going to use substitution. So X equals 4 minus Y. So I'm going to substitute in X. So 3 times 4 minus Y plus 31Y equals 110. Go through the solving kind of quick. 3 times 4 is 12 minus 3y plus 31y equals 110. So then I'll have 12 plus 28y, combining those like terms. 31 minus 3 equals 110. Let's subtract 12. So 28y equals 110 minus 12 is 98. Divided by 28, so we get y equals 3.5. So then x is equal to 4 minus 3.5, which is 0.5. So that means we walked for 0.5, we walked for 0.5 hours, and then we rode for 3.5 hours. So we're pretty far on our trip before the bike chain broke. So we had to walk for a half hour, where we had to ride for 3.5 hours. Next, we have a mixture problem. So Doreen is a chemist. She needs to prepare 36 ounces of a 17% hydrochloric acid solution, find the amount of an 18% and the amount of a 9% she should mix together to get this solution. So we have a mixture problem. If you think back to going to mixture problems, there are ways of doing this without creating a system, but systems would definitely help. So we have the amount, so the amount of ounces, here let's just say ounces. And then we have the strength. And then that will give us the amount in ounces times its strength would give us the total. So let's call it total. So we have, in the end, we want a 17% solution. So I'm just going to call this the last row the 17% solution. And what are we mixing? We're mixing an 18% solution with a 9% solution. So the amount of ounces in total, I want 36. It says right here, 36 total. But I don't know how much of each I'm mixing. I know I need 36 in the end. So I could say X amount of ounces of 18% solution plus Y amount of ounces of 9% solution is going to give us the 36 total. So then the strength is the decimal value of our strength here. So 18% is 0.18. 9% is 0.09, not 0.9. 0.9 would be 90%, but 0.09. Then the total would be 0.18 times X, 0.09 times Y, and, oops, sorry, I forgot the last one, 0.17. So this is going to be 36 times 0.17. So then we can just take out our information. X plus Y is equal to 36. The amount of ounces of 18% solution plus the amount of ounces of 9% solution is going to give us our total amount of ounces. And then we could take our last column, 0.18 X plus 0.09 Y is equal to, I'm going to go ahead and just multiply 36 times 0.17, get that done, which is 6.12. And there's our system. So now we can just go through and solve that. So I'm going to subtract Y from both sides. So X equals 36 minus Y. Substitute it into there. So 0.18 times 36 minus Y plus 0.09 times Y is equal to 6.12. Be pretty quick about the solving here. So 0.18 times 36 is 6.48 minus 0.18y plus 0.09y equals 6.12. I'm going to combine these like terms, and I'm going to move over this 6.48. So negative 0.18 plus 0.09 is going to be negative 0.09 equals 6.12 minus 6.48 is negative 0.36. Divided by negative 0.09. We get Y is equal to 4. Y is equal to 4. So then that means X is equal to 36 minus 4, which is going to be 32. So 32 ounces of the 18% and 4 ounces of the 9% solution is needed. You could write this out nicer if you want. 32, 9% is 4. Fun problem. So going back to mixtures, this was always a tough scenario. If you go back to some other problems where we just set up linear equations, just using a single variable, it was a little bit difficult at times. So I think 2 variables helps us out a little bit more. A little bit of some solving, but not too bad. All right, last problem. Scott and Carrie had a pottery stand at an annual craft fair. They sold some of their pottery at the original price of $12.50 each, but later decreased the price by $1. If they sold all 89 pieces and took in $1,049.50, find how many they sold at the original price and how many they sold at the reduced price. So we have an original price of $12.50. We sold some amount, but then we decreased the price by $1. So let's keep that in mind. We have $12.50 times some amount that we sold plus $1. I'm sorry, not $1, but we decreased by $1. So then we sold them for $11.50, and we sold some amount. And together we made $1,049.50 in the end. So there is our first equation. So again, I sold at $12.50 times some amount, and then I decreased the price by $1, so $11.50, and then we sold some amount of that. And together we sold this amount, $1,049.50. The total amount of actual physical objects sold was 89. So that's going to be X plus Y is equal to 89. Because we sold some amount of the $12.50, we sold some amount of the $11.50, and that was 89 total items. But then the value of those items were here. $12.50 is the value, $11.50 is the value, and that gives us our total value. So there is a difference there in how we set that up. But at the end of the day, there's our system. Let's solve it real fast. So X equals 89 minus Y. I'm going to substitute in for X over there. I'm going to do $12.50 times 89 minus Y plus 1150 times y equals 1049.50. Distribute, so 1250 times 89 is 1112.5 minus 1250y plus 1150y equals 1049.50. Going through the solving pretty quick. Don't want to waste video time here. 2 steps, combining like terms and subtracting that over. So negative 1250 plus 1150 is negative 1y equals 1049.5 minus 1112.5 is negative 63. So that gives us y equals positive 63. So that means x is equal to 89 minus 63, which is 26. So we sold 26 items at the $12.50 price, and then we sold 63 items at the $11.50 price. Because we had the $12.50x, $11.50y, so the x was the amount that we sold at the $12.50 amount, which was 26 items, and then the $11.50 amount was 63 items. I think that's the last problem. Yeah. So tough lesson here with both part 1 and part 2 put together. Solving systems of equations with problem solving. Tough section.